हेलो, गुड इवनिंग कीर्तना.
Good evening, ma'am.
Where you have joined? Kirtana?
Yes, ma'am.
So where you have joined earlier?
I didn't get the link, ma'am, the joining thing.
Okay. Yeah, we were doing the chapter that is the thermodynamics in the last class, right? Majority of our
Yes,
time
ma'am.
has been wasted today. Well, no issue. Did you do the revision of this part that we done in the last class?
Yes, ma'am.
Okay. So it was all clear to you or still having any doubt?
No doubt, ma'am.
All right. So we were doing the topic that is the internal energy, right? So what is the internal energy? Basically, in any system, the amount of total energy that has been in the system that we call as internal energy, right?
Yes, ma'am.
Okay. Internal energy we represent it by delta U. It is U basically, and we study about the changes in internal energy. So the change for the internal energy we represent it by delta U. Clear?
Yes, ma'am.
The internal energy depends like how much substance we have. Like we are having 10 grams, we are having 20 grams, whatever we have basically, it depends on that. So we can say that internal energy depends on quantity of substance, like how much quantity we have. Clear? So
Yes, ma'am.
basically what happens, we have two types of properties. One is the extensive property, other is the intensive property. Extensive property are the properties that depend on the amount of substance. Extensive properties depends on amount of substance, and these do not depend on amount of substance. If I say that temperature, if I say temperature, so will the temperature depends like if you are having a one room and if you are having a house, so will the temperature will vary in the room and in the house?
No, no.
It will remain the same because it is not depending upon the quantity. Either it is the larger one or the smaller one, it remains the same. है ना? If I say
Yes, ma'am.
that we are having density, either you are having 2 ml water or either you are having 1 liter water, the density for water is 1 always. है ना?
Yes.
If we say that it is the mass, so mass of a single substance and mass of a lag jayegi, bigger one is basically the different, like you are having a small cube or you are having a bigger cube. So it depends on the quantity.
Yes, ma'am.
So we can say that it is an extensive property. So the properties that depend on the amount of substance, we call it as extensive properties, and the quantities that do not depend upon the amount of substance are intensive properties. Clear?
Yes, ma'am.
Kirta, just wait. Yeah. One thing is that for any substance, we cannot calculate the internal energy. Like we say na, that we study about the ideal systems, but in nature, no ideal system exists. Like we do it in Raoult's law.
Yes, ma'am.
We have studied na, that ideal solutions are there, but in nature, no ideal solution is there. So in the same way, we can say that absolute value of internal energy हेलो हाँ ठीक है मैं अभी करती हूँ तेरे को रुक जा क्लियर इज इट क्लियर कितना
Yes, ma'am.
Okay. Next thing is basically how the internal energy changes. Means we are studying about delta U. So the thing is that how it changes basically, it depends on some factor, that either my matter is entering the system or it is leaving the system. Either my heat is entering the system or heat is leaving the system. Either I am doing the work on the system or work is done by the system. Clear? So delta U depends on three things. First is matter. Either matter is entering the system or leaving the system. Heat is releasing or we are providing the heat to the system. Or work is done on the system or work is done by the system. Clear?
Yes, ma'am.
These three factors changes the internal energy. But the one thing that I can say that total energy of the system remains the constant. Total energy of system remains constant. Clear?
Yes, ma'am.
If we say that energy is released by the system, if energy is released means something is coming out of the system, then delta U is negative. If energy is absorbed by the system, then we can say delta U is positive. Or we can say if energy is released, we can say exothermic process.
Yes, ma'am.
So for exothermic process, my delta U is negative, and for endothermic process, my delta U is positive. Clear?
Yes, ma'am.
If I talk about isothermal process, like temperature is same. If my temperature is same, then no heat will be released and no heat will be absorbed. No energy will be released, no energy will be absorbed.
Yes, ma'am.
So I can say my delta U will be equal to 0. Clear?
Yes, ma'am.
Okay. Next thing is my internal energy depends on work. Clear? We have various systems. One is the adiabatic system. We have discussed about it. So the adiabatic wall that we have, we call it as boundary. It doesn't allow the transfer of energy or heat. Adiabatic wall doesn't allow transfer of energy as well as heat, but it allows work. Clear?
Yes, ma'am.
One more system that we have is isolated system. Isolated system doesn't allow transfer of heat and work. It doesn't allow anyone. Adiabatic allows only energy. Isolated allows no one, neither heat nor work. And adiabatic allows energy as well as heat. Clear?
Yes, ma'am.
Okay. Now the thing is, how do we convert or change the internal energy with work basically? If we say that we are doing the work on the system, means we are providing the energy to the system. So work done on the system means it should be positive. Can we say this thing?
Yes, ma'am.
If we say we are doing the work from the system, we are getting the work from the system, so we are releasing the energy, we can say.
Yes, ma'am.
So if it is releasing, then my delta U will be negative. Now the work is that
Yes.
like which type of work our system can do. It can be either mechanical work or it can be electrical work. Clear?
Yes, ma'am.
Electrical means we are providing a source. Mechanical, like we are doing it ourselves.
Yes, ma'am.
Okay. So whatever the work we are doing, it doesn't depend on the path. It depends on that how much work we have done on the system. It is not up to that how we have done this work. It is that how much work been done on the system. So we can say that it is a path function or a state function. So it is a path function,
Yes, ma'am.
right? So in this way also we can change the value of internal energy also. Clear?
Yes, ma'am.
Okay. We will discuss more about internal energy change in the next class. So, okay. Okay, Kirtana?
Okay, ma'am.